Hello and welcome to TidyX episode 120. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward, and today we're working with columns.
Oh yes, we're working with columns. We thought that it might be a good time to kind of go back and look at. We work with columns a lot. Obviously, we use a lot of these functions pretty regularly in past episodes, but we kind of gloss over them at some point. We're like, oh, we just selected these columns and move forward, and or we go, oh, we grabbed them like this and move forward. But we don't really go into what are the variety of different ways that you can grab these same columns. What is best practices? What we think are best practices when you're doing this. How can you just a variety of different ways that you can work with this. We also at the very end answer a question that we got from one of our viewers. So this is going to be a very fun, hopefully educational episode. So I will close this a little bit so that y'all can see the code here. All right, so this is episode 120, working with columns. So we're going to load two different libraries here. Tidyverse for our data manipulation needs, such as working with columns. And then we're going to use library rvest. So the reason we're going to be using the rvest package is because we're going to be pulling some data down from the interwebs. Specifically, in celebration of the Mariners making it to the playoffs for the first time in 21 years, we are going to be looking at Mariners data. We're not going to look in depth in it. We're just using it as a sample data set, but I thought it would be fun to do so for all our Seattle fans. So we're pulling this from baseballreference.com. This is the franchise level, season level data. So we're going to pull this. We're going to use the read HTML function. We're going to then throw this into the HTML table function. And what that does is that's going to pull the tables from the website and put it in data frames in list form. Then we're going to use the pluck function, which is intended to be used for lists. And this will pull the first table from this list here. So we can quickly run these two lines first, and you can see that there's only one table, and it is the franchise level statistics that exists. So let's rerun that with pluck to pull out that one table here, and boom, there you go. We've got a team stats table where it's got year, team, league, games, wins, ties. So a variety of different columns for us to work with while we do this. Patrick, do you want to take us through the first selection semantics?
Yeah, so initially when you get your data in, you might be thinking, well, which of these columns do I want to look at or utilize, and which columns don't I need to keep, which is sometimes important. You just don't want to have these massive data sets flying around. Sometimes it's cumbersome to work with. So there's a number of ways you can select the columns of interest. The first one is actually this select function, which is just basically pass the exact column name and you're going to get it returned to you. Just remember, if you do have columns that have spaces in them or funky characters like the percentage sign or the hyphen, you're going to need to put those little, they're not quotes. What are those?
Ticks.
Yeah,
the
ticks.
Ticks.
Yeah, ticks.
Back ticks.
Put the little ticks around them, which basically just tells R, like, hey, everything contained within this tick is one single thing. So if we run this line of code, you're going to see that we're going to get back returned to us these nice 7 columns in a handy data frame that we could work with and analyze or plot or do whatever with. Using select, we in that first example, we directly named the columns that we wanted. This is the preferred way to do it because let's say, for whatever reason, Baseball Reference goes in next year and they add a new column or they add new columns somewhere and they don't put it on the end in the schema. They put it like somewhere in the middle. And all of a sudden now all of the column numbers are off. If you were to do this second option where you're selecting column names by numeric position, and for whatever reason, the underlying data schema changes, you now have a problem because column 9 is no longer what you thought it was originally. What was originally column 9 is no longer column 9. You're getting returned something back. So you can select by number, which we'll do here, but it's just a little bit more dicey. You got to be really sure that the data schema isn't going to change underneath you from year to year. So that's two of the ways. Another way is that you can actually use these cool, handy functions called ends with and starts with. And basically, what these do is they're like think of them as like quick and dirty string parsers. You're basically saying, hey, take a look at the column name, and if it ends with W-L% or it starts with R, go ahead and grab those two. Now, the only issue with this is that they might grab stuff that you're not interested in. Like R is clearly for runs, but maybe we have like runs on errors or something like that that gets added into the data next year. That's going to get yanked out as well. The typical time when I use starts with or ends with is if I'm building new features, like let's say I'm doing mutate and I do across, let's say something like wins, losses, and win percentage, and I create maybe like a scale value, like a z-score, and I name those columns, let's say like column name underscore z. In that instance, I would then do like ends with quote underscore z, and that'll give me the chance to extract out only those variables that I've already sort of applied some sort of function to or statistical information to. Same thing with averages, standard deviations. I might do underscore average or underscore mean or underscore SD, and that's how I would select those out. So that's where these really come in handy. But for our purposes here, they'll work just fine because we're not changing the columns.
Yeah. So I was just typing down kind of.
Yeah.
This code will probably not work, but clearly making stuff up. But I think this is roughly kind of what you were talking about.
Yeah, exactly. So that'll. Other ways, if you want to be a little bit more explicit, you can use matches, which is we did do a whole 2 episodes on rejects, expressions, and all of that stuff. So you can kind of search those 62 and 63, but matches will go ahead and look at those column names and it'll say, okay, find the matches for this regex expression. So here we're passing it W, we've got the bracket around the hyphen L, the percentage, and then the dollar sign is basically saying grab any columns that are, have this, and then ends with this, The other one is the caret is telling us any columns that start with the R. So match up any columns that start with R. Same concept as above, just a little bit dirtier, and
it can be a little bit more flexible if you have to do kind of a bit of a fuzzy match or something like that, where you're like, well, it's usually like this, but there might be a pattern, or might be something a little bit weird about this. Starts and ends with, use that pretty regularly. Contains is another one that rather than looking at the beginning or end, it's just, does the string contain, does any of the column names contain this pattern anywhere in it?
Right.
So if you wanted to grab every single column that had a % sign in it, that would be a situation where you'd use contains, where it'd be select contains % sign, and it'll literally look for the % sign in any of the columns.
Another way that you can select some columns is you can select on a condition, which is sometimes useful to do. So here, for example, we have our stats, team stats data frame. We're going to mutate across everything as character. And then we pivot this data longer. So just for the purposes of this example, we're going to pivot this longer. There's probably no good reason to do this.
This was for demonstration only. For some reason, a lot of times, you're working with somebody that is used to working in Excel, and they'll give you some time series data, and for whatever reason, this is not a judgment, but for whatever reason, you tend to see people list time series data by column in Excel.
Right.
So they're
reading left to right based on condition. If it was in a long format, I think they'd have to always filter to the condition that they want and then look down the page. So they can quickly look left to right
and just scroll
by
across,
compare. And so it I guess intuitively for the viewer, it makes some sense. So we just create a little data frame, which is the one down there below, which is stats wide. So you can see team is the condition, but we're only dealing with one team. So it's going to be Seattle mariners repeated, 19 times down the page. And then we have just all of the statistics are the other condition. And then across the top of the data, we have the seasons, and they are in ticks because you wouldn't have column names that are numbers. So R puts them in ticks. And that's what happens. Right. So now selecting based on a condition, we're selecting team and stat columns. So we're keeping the two conditions. And then what we're going to do here is we're going to say where, and we're going to pass this function X. And within this function, the suppress warning is basically because we don't want to see R barking at us in orange, in an orange warning at the bottom. But what we're going to do is we're going to change the values in row 6 to numeric. So row 6 is our win-loss percentage. So you can see that they have quotes around them telling us that they're character values at the moment, because everything above them has some non-numeric values. So R has changed them all to character values. And we're going to say, hey, if this is true, if the value is greater than 0.5, which is the where condition, wherever the value is greater than 0.5, that's what we want to select back. So if we run this, we get our team, our stat, and we get the years, the seasons, where the win percentage for the Seattle Mariners was greater than 0.5.
See, they had a winning season on average.
Those are the winning seasons. Yeah.
So you can see the dearth of a few years between 2009 and 2014, and then of a
little lull. Yeah. Back at.
Yeah. So yeah, that's fun, and now we're in the playoffs. So it's all good fun. But yeah, so that's how you could use select and select statements to be grabbing different columns from your data set. You get a big dump of data, and you're just grabbing different columns that you want to use, and several different strategies you could use to grab the data that you want to be using. But likely, it did not come with column names that are useful for you when programming. Like we saw, you have to throw backticks around things up here, and that can kind of be frustrating and kind of cut your flow as you're programming. Remembering capitalizations could be a massive pain. So let's rename these columns. And so the way where you can do this is when you're doing a select. If you're explicitly calling columns, you can do a select and rename them at the same time, which is pretty nice. And here it works where the left-hand side is the new name you're going to be assigning it, and the right-hand side is the original column name, because that's the column in the data set that you're pulling. And so here we're going to convert year to season, W-L% to win-loss percent, Pythagorean win-loss percent to win-loss Pythag, so that we could, in the future, if we wanted to, do a starts with win-loss and get all our win-loss columns. Same with run scored. We know it's R, but in the heat of trying to figure something out, we may not remember that R stands for runs, and so we convert that to run scored. So this is a way, if you want to manually rename every single column that you're pulling, this will work. But renaming does not work if you're using a starts with or ends with or something like that. So this is not an end all be all. There are other ways to rename columns, because otherwise you have to do it like this, and that's kind of a massive pain. What you can do is there is a handy dandy function called rename. What? And it's almost like it does what it says, where you can rename columns. The nice thing about this is, even though here I listed all the columns that we have and I'm renaming every single one of them, if for some reason I was fine with, say, year, I didn't really care about changing that, I just delete that, and it still works, and we still have the year column, because this isn't a select. This is just telling R, hey, take the column W-L%, change it to win-loss percent for me. It's not saying select or deselect any of these columns. And so this is a good way to do this. Oftentimes I'm changing one or two column names for me to be working with, and it's just it's a column name I don't really like, or it's kind of a pain to work with, so I just convert it over. You can also have, there's a version of rename where it also accepts a function, and so then you can start applying patterns to name changes if you want to. And so here we come up with, once again, these are kind of pedantic because we had the data set that we worked with is actually not too terribly named, but I wanted to come up with ways to show you all how to do this. And so here we're grabbing any column that ends with win or loss, so win-loss or Pythag win-loss, and I want to convert it into a nicer name. So we're going to throw it into this function, and now any column that has win or L, we're going to replace that column name where it has a percent sign and replace it with the string underscore percent, or PCT, standing for percent. And then any case it sees the W-L, replace it with win underscore loss. And so we can run this one real quick, and we can see that it's changed it to win loss percent, and then Pyth win loss percent. So it's not like the nicest, but it'll get the job done for us. And then similarly, if any time a column starts with an R, we're going to replace R with runs underscore. I just added that underscore in there so it looks a little bit nicer. That's why I didn't do that, because we don't want it. Let's do it like that. So now it's going to replace R with runs, and then the RA converts it into runs A. So it makes it a little bit nicer to work with. Of course, there is the fantastic janitor package that can save you from having to do all of this. It's going to make some assumptions, and so it's maybe not always going to be perfect, but it's going to get you a good chunk of the way there. So we're going to take these selected.
I've never met a janitor assumption I didn't like.
That is fair. And it's now converted it into WL percent, Pyth, WL percent. It left them R and A because why would it know that it's runs? But it's also made all of these lowercase, which is just nicer to work with. And so that's how you can rename these columns into something that's a little bit nicer for you to work with. Next, what if the columns aren't in the right order that you want them in? Because sometimes order actually matters for what you're working with, the column order. So you can do that with selects. And this is actually, I see this all the time with like code that I'm reading from other people, where they take the data that they're supposed to be working with here, and they go, select, and I want season, but actually I want finish. Like, where did they finish in that season to be listed right after that? How many games back were they? And then I want everything else. And you know what? That works. Grabbed season, grabbed finish, grabs game back, and then grabbed everything else. It worked exactly as you thought it would. But it can lead, unless you understand the semantics that are going on under the hood, it can lead to some weird things that you may not expect. So Patrick, when you see this select statement, what do you think is going to happen?
I'd expect us to get season, then finish. I'm saying I don't want games back, but then give me everything else. So I expect season, finish, everything else, and no games back column. But that's not what
we get.
We
get games back dropped at the very end. And that's because the way that select works, when you actually put a negative in front of games back, it is not reading it as remove games back. The way that it actually gets parsed under the hood, unless Hadley and the team change this in the future, but this is how I understand that it works. It is actually selecting all the other columns that exist. And so in this situation, it's saying, give me season, give me finish, grab all the other columns other than games back, and then we're calling everything again, but everything, this function everything respects direct selection ahead of it. So it'll respect season, it'll respect finish. This is saying all the other columns to keep, but it doesn't see that you actually tried to remove games back. So it's actually going to try to keep games back for you, which is why games back gets thrown on at the very end. And so I see this happening fairly frequently for people. So the way that you can get around this is a very simple function that actually is a lot more explicit. And I think this is the way, if you're moving columns, you should be doing this. You pipe into the relocate function, and the relocate function accepts n number of columns that you plan on working with. And so in this case, the only two we're working with two columns, finish and games back. You can work with one, you could work with 10. Doesn't matter. Then you specify where you want it to go. And this is in reference to another column. And so in this situation, what we're saying is I want to relocate finishing games back to after season. And so this will move finishing games back to after the season column. You could also technically do before, and note that it's a dot. And that the idea is that this is unlikely to be an actual column name. And so you can do this, and this will put them at the very front of your data set. The first two columns. I like to have season at the very beginning, so we can move it to after, and here they show up at the very end.
Yeah, that's a massive function. I use it all the time if I'm doing building like markdown reports or Shiny apps where I have tables, and maybe I've created some like summary features that obviously when I create them, they get locked onto the end of a table, but I want to move them. And so sort of like right before I pipe in, data table or GT or React table or whatever package table I'm using, I throw in this relocate. So I make sure, hey, this is the order. Now give me the table. Everything looks good to go. And it's easy to do.
Yeah, it's a nicer way. It's clearer what's supposed to be happening. You're being explicit about what you expect to be happening.
Yeah.
Here, this is kind of more a side effect. Things are kind of ending up the way you want them to. Because I mean, you're not wrong in this statement here, but you're relying on something behaving. It's like undocumented use of this function. Select is not intended for your reordering of columns necessarily.
Yeah.
This is. Cool.
Mm-hmm.
All right. So the last way that you can work and interact with maybe not the last way because there's mutates and all these other things, but we're not talking about changing columns. We're talking about like working and pulling out columns and reorganizing, is pull and pluck. And so pull is from dplyr and pluck is from purrr. And so that should give you a hint as to what these two functions' intent is supposed to be. Purrr is for working with lists and iteration. Pull is from dplyr, so working with tables. And so pluck, and you can read this in the documentation, is essentially a wrapper around the double square braces. And so that is how you can interact with lists. So you can have a list, that's 1, 2, 3, 54, I guess, and 4 down there at the bottom. Let's call that L. The way you work with lists is you use double square braces to select out the contents of a list. And so pluck, when you work with team stats, if you've ever worked with the data frame or Tibble, let's type this out real quick. If you ever worked with one of those, you can select out a column with double square braces. So this is why this works, is because this is a wrapper around double square braces, so you can select out a column using pluck. But that is not necessarily what it's intended for. Pull is designed to work with tables, and so it's more coincidental that pluck works similarly to pull. But pull has some nice like quality of life features in it that pluck doesn't have. So if you're working with tables, use pull. The first one is I don't think you can actually use TidySelect. Can you use TidySelect semantics? You cannot use TidySelect semantics with pluck because that's not what it was built for. You can't use the column name because you can't use the column name in square braces. But you can with pull. And so here you can say, I want to pull out the win-loss column. Let's actually simplify that and do that. So cool, we pulled out the win-loss column from team stats. But there's also a handy-dandy feature where there's an argument called name. And name allows you to select a column that is not the column that you're trying to pull out, but you can use it to assign names to the vector that you're pulling out. And so in this situation, I'm going to call it year. And so when we pull out the win-loss percent, but I want to retain this year information, I can use name equals year. So I pull that out, and now it's a named vector. It's still a vector, but it's a named vector. So I can access this one in, let's call that
V.
V. Let's call it V.
V.
From V, if I want to pull out year 2022, I type in 2022, and it'll pull out that column for me. I don't have to remember the order in which it was in. So that's real nice. Yep. And then finally, pull defaults to assuming you want to pull out the last column. It does not do anything weird, but pluck, if you don't pass anything to the double square braces, it doesn't select anything. So double square braces returns the entire data set for you. And so they're just slight differences. It's a coincidence that you end up with similar values. And I know that I think in the past we might have kind of used them a little bit interchangeably at times in situations where it worked. For the most part, you should probably be using pull instead of pluck.
Yeah. I only use pluck if I'm like dealing with a list, mainly like web scraping, and I'm trying to get tables from a page.
Exactly.
Pull tend to use a lot inside of functions where I have maybe like a table of data, and I'm building like a Monte Carlo simulation or a Markov chain, and I want to extract the values from a column that I'm maybe sampling or simulating from or something like that. So pull, I tend to use a bunch more.
Yeah. But cool. But that is how you can work with columns using Tidyverse in a variety of different ways. You can select them using, the numeric values, the specific column names. You can use pattern matching, which is super useful. Condition matching. You can rename them. You can rename all the columns. You can rename some of the columns. You can relocate them. And then you can pull and pluck out columns. Well, you should pull columns, not pluck columns from your data sets. And with that, I guess we're going to call it. Thank you all for joining us for 120 episodes. As always, my name is Ellis Hughes.
And my name is Patrick Ward. And you can find us on Twitter collectively at tidy_explain. You can hit us up on our Gmail, tidy.explain@gmail.com. Most likely way to get a hold of us is go to that YouTube page, like and subscribe, and drop your comment question down below. And maybe, as we did today, we'll answer yours live on the air. Other than that, we enjoy doing this. And if you feel like you've enjoyed it and it's benefited you in any way, we do have a Patreon page. We're always grateful for whatever anyone feels like they'd like to contribute. And that is episode 120.
Thank you all so much, and keep on exploring your world.